So we're going to talk linear inequalities today, and we're also going to, why is my, oh, I guess it is working. I didn't see the green light, but now I see the green light. And we're going to solve them and graph them, and we're actually going to interval notation. So, a bunch of stuff. So first off, let's refresh our memories with what the inequalities actually are. There are 5 of them. Okay? The first inequality is just a straight up less than. Okay? And that's just I call it the alligator. Okay? All right? Then there's the greater than its counterpart. Then we got crocodiles. Less than or equal to, greater than or equal to. The one that you probably rarely see, or that you probably didn't even know existed, is the not inequality. So those are our 5 inequalities. Now, last week, Thursday, once we were talking about equalities, we found an exact value. So like we said, x is equal to 5. And that's what makes this be a true statement. Okay? When we're dealing with inequalities, okay, when we say now we're going to have an entire range of values. So our range might be from 5 to infinity. We all make that statement true. Or it might be from -3 just to 4. Those might be the only values to be true. That's what we're talking about when we're talking about. Okay? The way we go about graphing them is we graph them on a number line. Okay? Now, I've got a real fancy number line up here, only because I stole it from a picture. Okay? But your number line really only needs to contain 1 or 2 numbers. And those are the numbers that are involved in your solution. Okay? So we graph our inequality on a number line, and that is going to have 2 parts in it. The first part is the dot. Okay? So if we are less than or greater than, our dot is open. So it's basically just a circle. Open dots. Right on that number on our number. If it's less than or equal to or greater than or equal to, we fill in that dot to signify that that number is included in it. Then we draw an arrow above the line because we want to be able to see it. So what I'm talking about here is this. Let's say that our solution is x is less than 3. That's our solution. Okay? That's the inequality, because it's written in inequality. An answer could be, or a graph, if you will, we would have 3 on it. We would have an open circle at 3, and we would be going up, and we want numbers smaller than 3, so we would be going back. That is an acceptable graph for an inequality. I would also accept that as a graph for an inequality. Okay? Both of those are acceptable graphs for x is less than 3. That is not an acceptable graph. Okay? Just know the fact that you're probably going to do your homework, do your tests, do your quizzes, do everything in either pen or pencil, and that's it. You're going to be you're a monocolor producer, if you will. Okay? Some of you I've seen have used multiple colors, in your notes, and that's great. More power to you. I'm multicolored type. I live in the multicolored verse. Okay? But some of you are just one color. Okay? That last one is not acceptable because I don't know which way it's going. I know 3 is not included because I see the circle around it, but I can't distinctively tell which way it's going. Okay? And I need to be able to easily see which way that's going. So that is not acceptable. Okay? Then the other part is interval notation for that same thing. Okay? So with interval notation, when we have less than or greater than, those are parentheses. Okay? So we put parentheses next to that numeric value. When it's the equals component, we change those parentheses to brackets. So when we have the inequality x is less than 3, okay, so 3 is going to have the bigger, so you're going to always have 2 numbers in it. You're going to have the smaller number on the left, a comma, and then the bigger number on the right. Okay, so you're always going to have that. So if I want numbers smaller than 3, then my smaller number is negative infinity. It's going all the way to negative infinity. Comma, my big number then would be 3. Okay, because 3 is the biggest that it could be, but not equal to. Okay. Questions, comments, concerns, clarifications? All right. One more rule to go along with it. Okay? When we're solving inequalities, they're solved the exact same way that we were solving things on Thursday. What we do to one side, we got to do to the other. We want to get our variable all by itself and the number on the other side of whatever we have. We want to do the opposite to move things to other sides. All of that stuff is the exact same thing. Okay? But there's one extra rule, and that extra rule is that if we multiply or divide by a negative number, our inequality is going to flip-flop. So if it was less than, it becomes greater than. If it was greater than or equal to, it becomes less than or equal to. Okay? Not if we're dividing into a negative number. It's only if we are multiplying or dividing by a negative. So let's get into let's solve graph and interval notation, all of this. Okay. So 4x is greater than or equal to 24. First thing that you would think about doing, so in your brain, you're thinking about it as 4x equals 24. And you're just solving. Okay? So what would be the first thing that you would solve? Yeah, well, what's the first thing you do? Divide by 4. Yeah, on both sides, right? Okay? And that's what we're going to do. We're going to divide this side by 4, and which means we got to divide that side by And then that's going to give us, now, we're dividing, which is that one of those multiplier divide ones. Are we dividing by a negative? No, so our sign doesn't need to flip, so we're good there. Okay? So then this just becomes x is greater than or equal to 6. Okay. Do I need to do any more? Well, I mean, I got to do more stuff, but solving-wise, do I need to do anything? No, so we're solved. Okay? Then we got to put it on a number line. The only number that I care about is 6. Okay. Open or close dot? Closed, because it's got the equals component. Do I want bigger numbers or smaller numbers than 6? Bigger, right? Because the alligator or the crocodile eats the bigger number. So does that mean I'm going left or I'm going right with my arrow? Right. Going right. In interval notation, the smallest number that I can be is 6. The biggest number that I could be, positive infinity. I know I can't get to infinity, so that's always going to have a parentheses. Do I have a bracket or do I have a parenthesis at 6? I have a bracket because of the equals part. Okay. So this one right here, this is my inequality. This is my graph. And this is my interval notation. All three combined give me the exact same answer. Well, on the quiz I can say, find me, give me the answer, solve this inequality, give your answer in inequality form, or give your answer graphed, or give your answer in interval form. So I can have 3 different versions of the exact same problem. Yeah. Okay. Love it. B, talk to me. What would you do first? Subtract 8 from both sides? That's going to give me negative x is greater than 9. Okay. So I'm dividing, or could I multiply by -1? Same thing. Yeah. Same thing. But I'm dividing by a negative. So what does that mean? Flip that sign. Yep. Okay. So then this becomes positive x is less than negative 9. My graph would then, the only number on the number line that I care about is -9. If you put more, that's fine. I got no problem with that. But you better have the number up there that's in your inequality. Okay? Open or close dot? Open. Left or right? Left. Interval notation would then be from negative infinity all the way up to -9, and I would have a parenthesis. Questions, comments, concerns, haikus? Love it. Okay. You try those two. Solve graph and interval them for me. First step in C. Subtract 2. So that is 10 is less than or equal to -4x. Then divide by -4. What happens? It flips. Do I like -10/4? Negative 5 halves I like better. Yep. Okay, so we can write this as negative 5 halves then is greater than or equal to positive x. Okay, all right, love it. So then we can graph that one. Again, here's the nice thing about fractions is that it's the only number that I got to put on there, so I can just put on whatever it is. Okay? We don't have to figure out the decimal equivalent of it, even though we know it's negative 2.5. But we don't have to do that. We can just go right there. Boom, done. Open or close dot. Close dot, left or right arrow. Left. Okay? Which would mean negative infinity to negative 5 halves with a bracket. Questions? Good. Love it. First step in D. Distribute 5. Okay. So then that gives me 5x minus 6 is less than or equal to 5x plus 5. Okay. Then what?
Add 6 and subtract 5.
Okay. All right.
Add 6 and subtract 5.
So I'm going to add 6. And I'm going to subtract 5x at the same time. So then that gives me 0 over here and 11 over there. Right? Why is there a solution? More importantly, why is it not no solutions like you originally thought?
Because it's still there.
It's a true inequality. Yep. So that therefore it's not no solutions because it's true. If it were reversed, then it would be no solution because it'd be a false inequality. Okay? So instead of it being no solution, what is it? No. Because if you would have gotten negative 6 is less than positive 5, or less than or equal to positive 5, that still would have been a true solution. Or negative 11 is less than or equal to 0. Depending which way you want to go. So what's the answer here? If it's not no solution, there's no variables, it's got to be what? Infinite solutions, or all real numbers. Okay? So the answer here is all real numbers, and on a number line, all real numbers, you can put whatever numbers you want on there. I mean, if you want to put 0, if you want to put 11, because those are the two numbers in your thing, that's fine. But you just draw an arrow all the way across. That's the graph for all real numbers. The interval for all real numbers is from negative infinity to positive infinity. So that then would be 3 different representations here. Okay. No solution would have the word no solution here. It would have just the number line. It wouldn't have anything else. And the interval doesn't exist for no solution. Copy. It's less than or equal to 0, which still is true. Yep. Yep. Compound inequalities now. Okay. A compound inequality is just simply multiple inequalities all in one. We've got 2 inequalities. It's very rare. Oh, sure. It's very rare that you'll have more than 2 inequalities in it. Okay? A compound inequality comes in 2 different forms. It comes in the AND form, it comes in the or form. The and form, both of the inequalities must be true in order for you to represent the solution. In the or form, one of them or both of them need to be true in order to be represented in the solution. Okay? Both of these are already solved for us. That's why I intentionally did it. Okay? So that's the inequality form for it. So now we would just need to do the number line graph. Okay? So we're going to have two numbers now on your graph. And you have to have both of them because both of them are important to the problem. So we have two numbers on our graph. Do we have a closed dot or an open dot at -4?
Open.
Closed at -4, right? Okay. So basically right now we're looking at that inequality. Okay. Which way would that arrow go? It'd go to the right. Okay. Now I'm going to look at this inequality. Open or closed there. That's open. Which way would that arrow go? To the left. So I would just connect those two lines. So that would be the graph of it. The interval notation for this one would be bracket at -4 and a parenthesis at 8. Okay. In the OR case, this one, just as a side note, this one I call a handle, because it literally looks like a handle. Like grab the handle on your backpack, like right there. There's one right there. It's a handle. Grab the handle on your backpack and go. Okay. In OR case, my two numbers are 3 and 7. Open or closed at 3. Open. Left or right with the arrow. Open or closed at 7. Open. Left or right with the arrow. This one called Roman vote for multiple reasons. One, it looks like somebody's rolling a rowboat. Okay? Two, what do you roll a boat with? An oar, right? Same. So it's an oar case. Boat. Okay? The interval notation for this one, so I'm starting all the way out here at -infinity. I'm going all the way up to +3. Then I'm picking back up at 7, and I'm going all the way out to infinity. The only thing that I have to add is in the middle here, I put a ginormous capital U. And that capital U stands for the union of those two solution sets. It's the union of those two solution sets. Because it's an OR case, if it's in either one of them, it will work. It just won't work Questions, comments, concerns? Love it. Try these two on your own, and then we'll go through them in a minute. So first thing I would do here in letter A is I would subtract 5 out of the middle. Okay? But if I'm going to do that, I've got to subtract 5 over here, and I've got to subtract 5 over there. Okay? I got to do it in all of the parts. If I'm doing it in one of the parts, I got to do it in all the parts. Okay? So then that gives me negative 15 is less than 3x is less than 3. What's wrong? Okay. All right. Then I'm going to divide everywhere by 3. And that's going to give me negative 5 is less than x is less than 1. Negative 5 and positive 1 are the two numbers that I care about. I want to be bigger than negative 5. I want to be smaller than positive 1. So we're there. Open dots at each. There are my 3 choices. Questions on that? Here I'm going to add 1. Divide by 2. Here I'm going to subtract 3. Divide by 4. So my inequality then becomes x is less than or equal to negative 3, or x is greater than or equal to 1. On the number line, we have filled in dots. And we'd be rolling the boat in an interval. It looked like that. Questions, comments, concerns? Haikus. The poem. 17 syllables. No, 3 lines. 3 lines, like 5. Like 565 or something, isn't it? I don't remember, but it's something like that.